Hello everyone, my name is Latin Ming. In Group 1, consisting of two members, Vivian and me. Before starting the presentation, I would like to thank you deeply for the knowledge you have imparted in the basic programming for electronic course.
First of all, I will show you the main topic covered in this presentation. Through the above topic, we will help you to understand our project better.
First, the key point and the most important knowledge that this whole project revolves around it is the electrocardiogram, or you can call it ECG. But first, what is electrocardiogram? Electrocardiography produces an electrocardiogram (ECG or EKG), a recording of the heart is electrical activity. It is an electrogram of the heart, which is a graph of voltage versus time of the electrical activity of the heart using electrodes placed on the skin. These electrodes detect the small electrical changes as a consequence of cardiac muscle depolarization followed by repolarization during each cardiac cycle called heartbeat. The electrocardiogram is used for medical purposes to detect heart disease such as arrhythmia, heart failure, myocardial infarction, etc. There are three main components to an ECG: the P wave, which represents the depolarization of the atria; the QRX complex, which represents the depolarization of the ventricles; and T wave, which represents the repolarization of the ventricles.
Being biomedical engineering major, we immediately thought of this subject when given a list of W options for this project. As a result, we carefully consider how to create it using the most user-friendly hardware while still producing a accurate figure. We discovered a method for making it real after weeks of research. Blackview 2018, Arduino IDE, and Office 365 are the software that we use during the development of this project. With Blackview, you construct the software Arduino IDE to calibrate the Arduino board and IDE Office for completing remote and presentation.
By saying that we make it real, yes, it is real. We use AD823 True Heart Rate Monitor and Arduino Uno R3 board. Firstly, the most important part is the AD823 True Heart Rate Monitor. It is a cost-effective board used to measure the electrical activity of the heart. This electrical activity can be shot as an ECG or electrocardiogram and output as an analog reading. ECGs can be extremely noisy, so the sensor acts as an op-amp to help obtain a clear signal from the PR and QT intervals easily.
We use an Arduino Uno R3 board to collect the data from the AD8232 arithmetic. The Arduino is a perfect board to get familiar with electronic encoding. This versatile microcontroller is equipped with two famous processors. This board will give you a great first experience, which you was one of Arduino. Since the sensor output is an analog reading, we use Arduino to create a graph out of it. The ID8232 sensor comes with three electrodes. You need to place the electrode in the correct place and follow the three lead ECU rule. Remember to place it near the patient head to prevent noise.
This is our LabVIEW software interface, as you can see from the screen. Configuration and ECG tab is the name of our first tab of the interface. This page is used to set up LabVIEW and Arduino's input and output. Additionally, it is utilized to display the patient's heart rate and to indicate if the user's heart is beating quickly or slowly. The user's ECG wave created through the received data will be shown in the graph below at the same time.
Next ECG with editor tab, with EU to find the pick of ECG diagram, thereby used for subsequent calculation, specifically calculating the user PPM. As shown on the screen, pick will be put on the graph and the data will be sent to the calculation component later.
As you can see here, this is our hardware. We are using Arduino Uno board and AD8232 heart rate monitor sensor. By using this sensor, you need to place the electrodes in correct places. Follow the three lead ECG rules. Remember to place it near the patient's heart to prevent noises. After you have done with setup part, let me show you how we monitor the data we got from Arduino and sensor.
Further on, in the configuration and ECG tab, we need to choose Compose, which is the communication port between our laptop and the Arduino to transfer the data. After that, we need to set the parameter such as power rate and data bit and choose your file to save the data if you want to. Next to it is a waveform graph showing the ECG way and statement of the heart rate, such as tachycardia and bradycardia. As you can see here, the heart rate tab is showing that our patient heart rate is 90 ppm. If the patient heart rate is normal, the normal rate will light up. The same goes for tachycardia and bradycardia state. It is a ECG big editor. We have a graph showing the same ECG way as the one in our first tab. This tab up finding the QI bit of the way and one bit equivalent to 1 bit. After doing some research and measurement, we have calculated that the threshold should be 450 and the width between bits should be 3. By counting bits from the easy way, we will know the patient heart rate.
And as you can see, here is a summary of how our software operates on LabVIEW. After obtaining the ECG wave from LabVIEW, the limit level of peaks called threshold will be detected through the incoming data. At the same time, it will be displayed on the signal plot graph. After the threshold was found, the software will detect the peaks of the electrocardiogram to help calculate the heart rate. Also, the numbers of peaks will be shown in the table next to the graph.
When the calculation is completed, the BBM will be displayed on the interface and indicate whether the patient heart beating fast, slow, or normal. When the data has been fully gathered, the ECG wave will be displayed again on the graph of the interface. From there, we can diagnose the heart statement of the person being measured. The final results will be stored with specific date and time in Excel if you want to save your data as told before.
We intend to finalize our project in the future by including certain new features such as the ability to identify heart disease based on its symptoms, such as low blood vessel disease, coronary artery disease, or arrhythmia, also known as irregular heartbeats, heart muscle illness, and heart valve disease. The data will not be as exact as the methods found in hospitals, but both this project and future components will be appropriate for student skills. My team will make the finest feasible improvements and project optimizations.
We cover that accuracy is up to 92% through measurement utilizing our device compared to data obtained by using the BioWatt device in the school laboratory, which is a good result. To assure accuracy, we have taken several steps, including installing additional filters.
In conclusion, our goal in creating this project was to make it simpler for individuals who couldn't afford it, or in some situations, to manufacture a heart rate with monitor without spending a lot of money. Many people, including patients, doctors, and family members, will benefit from being able to quickly identify ECG waves because they are crucial in many situations. In the future, this project will lessen the number of people who pass away due to heart disease not being identified in time by assisting in the early detection of symptoms associated with the condition so that it can be treated swiftly. Thanks for listening.